All right, today we're going to look at similarity of triangles. Okay, so we have three types of similarity that can occur given by the theorems we're going to look at. Very similar to congruence of triangles, but similarity just means you're in proportion. So sides are in proportion, but angles would be equal. All right, so we have the angle-angle similarity theorem called AA similarity, and we would write that as AA, and the similarity symbol is a little tilde. All right, so it's the tilde that's above the congruent symbol, but without the equal sign under it. So that's our similarity statement. So if we have two angles of one triangle that are congruent to two angles in another triangle, so let's just draw two triangles. Okay. All right, and let's just say we have two angles. And let's say this angle here is congruent to this angle here in the other triangle. All right, and we'll name these ABC, and we'll name this DEF, okay, just for simplicity's sake. And let's say that angle A is congruent to angle D, okay? Well, since we have two angles that correspond to two equivalent angles or equal angles in the other triangle, then we know by default angle C and angle F have to be equal because of the triangle angle sum theorem. So therefore, we have similar triangles. So we would write triangle ABC is similar, using the similar symbol, to triangle DEF. Again, you still have to sync up A is to D, B is to E, and C is to F, so corresponding parts. In this case, corresponding angles to name, but you use the similarity statement. Okay, next, the side angle side similarity theorem. Same kind of idea as the side angle side congruence statement. Okay, so here we have a triangle. Again, we'll call it ABC. And we have a larger version of that triangle. We'll call it DEF. If we know that we have an angle of one triangle, we'll say angle B and angle E are congruent. And the sides that include that, so angle A here is say it's 2. Let's leave it at that. It shouldn't be congruent. And say this is 6. So 3 times 2 would give us the 6. If this BC side was 10, and EF was 30, again, 3 times 10 is 30, so our scale factor is the same, all right? Then we have side angle side similarity, okay? So what you do is you check your scale factor of 2 to 6, so 1/3, 10 to 30 is 1/3, or vice versa. 6 to 2 is 3, 30 to 10 is 3. And the angle is in between those similar sides, those sides that are in proportion. Then we have side angle side similarity. So triangle ABC is similar to triangle DEF, and it's by side angle side similarity. And we forgot to put up here that this one was by angle angle similarity. All right, so statement and reason, statement and reason. All right, next we have side 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 similarity. And side, side, side similarity, same kind of deal as side, side, side congruence. We'll use the similar triangles again, ABC, and a larger version of ABC. And if this is 2 to 6, and this is 10 to 30, and this is 20 to 60, okay, 2 to 6 is 1/3, 10 to 30 is 1/3, 20 to 60 is 1/3, or vice versa. Okay, 6 to 2 is 3, 3 to 10 is 3, and 6 to 20 is 3. If these sides are all in proportion, we have side, side, side similarity. So you write your similarity statement, syncing up your corresponding parts, and your reason is side, 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 and you can put the similarity symbol. All right, so let's look at 3 examples. Are these triangles similar, and why? All right, so we have R, W, S, V, and B, so that you can see it. And these are 45-degree angles here. All right, so right away, we don't have any sides that we're thinking of, but we do have vertical angles here. And we know that the 45-degree angles are also equal. So R syncs up with V, and angle RSW is the same as BSV, okay? So we have angle-angle similarity. So our similarity statement is going to be triangle RSW is similar to triangle. Now R corresponds to V, then we go to S, and we go to B. And it's by angle-angle similarity. All right, next example. Are these triangles similar, and why? Well, we have these two sides equal, so we have an isosceles triangle in AXB. We also have an isosceles triangle in RXC. So what we're missing is either a third side or an angle. But we do have angles here by vertical angles theorem. So we have similarity. I don't know what the measures are, but I know this length is in proportion to this one, as this would be. So we could just say this is 10, this could be 20. And this would have to be 20. This one would have to be 10 because they're congruent. So 10 to 20, 10 to 20. It could be 100 to 200, whatever, 41 to 51, 41 to 51. Doesn't matter. They're in proportion. So what we have is side angle side similarity, and our similarity statement will be triangle AXB is similar to triangle. Now A and B correspond to R and C any way you want, so it's up to you how you want to name it. I'll just name it CXR, but you could have easily named it RXC and it would be fine because of the fact that these are congruent sides. All right, and last problem, are these triangles similar, and why? Well, let's take a look. We have a 90-degree angle, so we know that these are equal. This is A, this is W, and this is L, okay? So, and this is M, this is P, and this is X, so we can see it. All right, so when we're looking at this, our longest sides are our hypotenuse, so we're going to say it's 15 to 20 from small to large, and that reduces to 3/4. So that's our scale factor. So let's check them out. We have to do every side now. Our smallest side is 9. Our smallest side here is 12. So 9 has to correspond to 12. So 9 to 12 is going to give us 3/4 also. So far scale factors are good. And then our middle side is 12, and our middle side is 16, so 12 to 16. And when we reduce that by 4, we're going to get 3/4 also. So that means that our sides are in proportion. So triangle, okay, I'm going to call this PXM, going from the right angle along the middle side, along the longest side, is similar to, going to start at the right angle, W. Now I went along the middle side here, I'm going to go along the middle side here, so it's going to be WA and to L. And it's by side, side, side similarity. And that's how you prove triangles similar to each other.